Hello there. Hello. You have a warm-up right there. Good morning. Let me hear one of your voices.
Good morning.
But
Good morning.
Morning. There are updates.
what do you want? Already started. Okay, and do you need something?
Yes, on the
What?
table, take out the.
Yeah, I heard that. Please.
Why this is a broken.
Hey. Excuse me. You need to mute. Thank you.
Good morning.
Good morning. There are updates in Schoology if you want to go take a look at those about retakes Wednesday and makeups if you missed the Zoom test. If you missed the Chapter 8 Zoom test, makeups are Thursday. Both of them are 2:50 p.m. to 4:30. Same 100-minute type window to get the test, take it, submit it. So check your updates for the details. And once everybody's in the, whoa, a lot of people are already here. That's good. So the retakes, there's no assignment in Schoology for you to upload it to. So those retakes, not everybody's doing it. Only a small percentage are doing them. You only get to choose one. I'll put all the chapters retakes up there at once. You get to just choose one and submit one. And again, it's only a small percentage of students doing it. No pre-approvals necessary.
Bottom right.
You guys mute.
You press the bottom right thing and then it's disconnected.
Mute
I got
your
it.
Shushi.
Mute your mics. Okay, so you guys try not to cut me off. I lose my train of thought when you do that. Okay, so there's no assignment in Schoology for a retake. You can't submit it where the test is, okay? So what you're going to need to do is you send a message to me and upload it into a message to me. However, on Thursday, that's Zoom test makeup. That's different than a retake. Those are students that missed the Zoom test. There will be version B for you. So when you turn it in, you can turn it in under the Chapter 8 test. It will say late. Disregard. It's okay. It'll say late because that assignment was due when we took it. So it will say late, but when I open it, I'll see that it's version B. And when I see it's version B, you will have the okay on that as long as you finish by 4:30. If it's time-stamped after 4:30, it won't count either. Okay, so that's makeups are Thursday at 2:50 or 3 o'clock. Okay, I'll have it up there by 2:50 though. And then the retakes are Wednesday from 3 to 4:30. Also, they will be available at 2:50. Okay, so hopefully that's clear.
Mr. Rosenthal.
Fact, only female mosquitoes bite.
Oh.
That's according to Snapple. You have this warm-up to do. So go ahead and do the warm-up.
Wait, what was the Snapple fact? I couldn't hear.
Only female mosquitoes bite.
Oh, yeah. I know that.
You knew that. Okay, good.
Mr. Rosenthal,
That's me.
for the homework, page 392, that's for lesson 9-2, right?
Right. I knew someone was going to ask.
Yeah.
You guys are good. You're ahead of the game. Yeah, I put it up there just so that, because while I was on it, I don't want to come back later and do it because sometimes I get behind. Oh, you must have noticed that I got up to date then on homework. Homework is now up to date. It's all been graded. So also I put in the 10-week report card grade. So that's all done. So I'm getting caught up on grading. So that just leaves the Chapter 8 to be graded. So expect that during spring break, to be done during spring break. I could do it sooner, but the district has us doing professional development. After this session with you, I have to do a district professional development every day this week. So that might take all my grading time away. So if that's the case, just look for it to be graded during spring break. All right, and then you guys should, by the time spring break is over, everything will be up to date and caught up. Okay.
Okay.
Where did you submit the report card? Like, how can we see it?
I don't know how they're going to get that to you. Somehow it's got to be mailed to you, but I don't know how they're going to do that. I don't know if Miss Diamond is going to go into the office and print them all out. I don't know. But the grades all have to be in by Wednesday. So I got mine in yesterday, and I sent it to Miss Welch. So then once Miss Welch has them all on Wednesday, she will give them to Miss Diamond, and Miss Diamond will have to, I don't know what the plan is for sending them out. Either the district is going to mail them or we're going to mail them out to you. But again, it's just a progress report. Schoology is what your grade is, not the 10-week. Okay, the 10-week is just a freeze frame of at that time on Sunday, what was your grade this Sunday? It's whatever the grade is now after that, after I put in the chapter 8, that's more accurate than the 10-week. Okay, time has started, so we can start our meeting. Let's, everybody's doing this warm-up. Hopefully you can see it.
Mr. Rosenthal?
That's me.
I don't remember. Did we finish 9-2 last week?
No, and that, I know you're seeing that homework there.
Yeah.
I'm getting ahead.
Okay, cool.
It's not due. No, look at the due date on it.
Yeah, I see.
Spring break starts this Friday. I see the comment and the question. So Friday, there's no school. Okay, and then all the next week, no school. And then we come back the following Monday. Okay.
Cool.
And we're not doing any Zoom meetings. I don't have any spring break homework for you. I just want you guys to, do what you want to do, the leisure activities that you're going to do, like reading a book, learning a language, whatever it is you want to do. Learn how to solve a Rubik's Cube, whatever it is. It's your time starting this Friday. Okay.
Wait, Mr. Rosenthal.
Yes.
Is the 10-week report card the official one that goes on our?
No, 20-week
Okay.
only. Your transcript, when you look back in history at your grades, only shows 20-week grades. Only. All right? So your transcript only shows when they decide to give you your credit for the course, for completion of the course. All semester courses, the only grade that counts is the 20-week grade in the transcript. The 10-week is more of a progress report. Okay? All right.
Mr. White, I have one more question.
Okay.
Are you still grading the chapter 7 quiz?
Whatever I had on my desk before we went on leave, I still have to grade that. The homework is caught up and I did the 10-week grades. That's what I've done so far. That means I've started the process. Now, because they have us doing professional developments this week, all week, every day, I may not be able to get to that grading, but you should expect to see everything updated by the time we come back from spring break. Throughout spring break, you can keep checking Schoology to see if I've done it. Okay, so, but I'm going to be taking the spring break time to finish all the grading. Okay? All right, so again, I'm going to say it one more time. Retakes this Wednesday from 3 to 4:30. I will open it up 10 minutes early. So at 2:50 p.m. on Wednesday, if you need a retake, I do not want you just taking a retake just to do it. It's only for those students who were going to retake that need it. And you can't take more than one. I'm going to put all the retakes from all the chapters this semester. I'm going to put them all up there. Don't do one you've already done because I will not count it. Okay? So if you're taking a retake, you pick one. Even if you need to retake more than one, you can only retake one, at least this week. We can talk about doing it again after spring break. But this Wednesday is retake day. When is it going to take place? It's going to take place after all your other obligations for the day. Excuse me. So I don't think you have any obligations at 3 o'clock, right? You don't have any other classes at 3, right?
Yeah, no.
Okay. So I wanted to make sure we avoided crisscrossing through other classes. So 3 o'clock to 4:30. If you can't make it, then you can't make it. Then you can't retake it. Okay. So it's on you. If you need to retake it, that's this Wednesday, 3 to 4:30. I will have it on Schoology in the Zoom test folder. All of them will be in there. You have to find the one you need, okay? And you will submit that one no later than 4:30. If it's later than 4:30, I will not count it. Those have to be submitted in the messages to me because there is no retake assignment, okay? All right, and then Thursday. I know that there are people that missed the Zoom test for chapter 8. I will be putting that chapter 8 test version B, I will be putting that one in the Zoom test folder on Thursday at 2:50. And it's the same deal as the retakes. You have to submit it no later than 4:30. That one, if you missed, I'm only speaking to those who missed the Zoom test. You can submit them right into the chapter 8 assignment. Because even though it says late on there, when I look at it, I'll see it's version B, and I'll know that you were doing a makeup. So it will tell you that it's late. Disregard that. It'll be okay. And that's the Thursday makeup Zoom test chapter 8 specifically. Okay? And it's in updates for everybody's course. If you go into period 2 or 3, you'll see it in the updates, the instructions of what I just said. If you need to look it up again, or watch the video later today after I upload it onto YouTube. Okay, let's get down to the math. Good morning, everybody. Happy Monday. Here we go. Functions. Functions are machines that help you predict the future of what's going to happen. So if you put in an input, a function machine will give you exactly one output. Okay? So these are different function machines. F of x, g of x, h of x. They all depend on what x is. X is the independent variable. We can put x, typically whatever we want or whatever the domain will allow. Remember, domain is whatever x can be. All right? But once you put in something from the domain set, an x, you have to get out only one thing. Okay? So when they say here h of -3, they're telling you what the input is now. Now the input is -3 for h, for the h machine, for the h function. So we're going to put in a -3 here for x. And we're going to find out what that is. 2 times -3 is -6. -6 minus 4 is -10. So this part here comes out to -10. Now that we know that we're going to now that we have what we're inputting into the f machine, that's f of x, we're going to be inputting -10 in there. We can now find out what we get out. So if I put a -10 right here, -10 minus 1 is -11. That means this is -11 right here. And that's what we're putting into the G machine. So if you put -11 here, you get -11 squared. And we know that that's -11 times -11. And a negative times a negative is a positive. So it should be positive 121. Are there any questions about that? I see the never mind 121. Yeah, some people got -121. They forgot when you square a number, it has to come out positive because of the negative times the negative. Any questions about that?
I had a question on so that the first equation, like what the equation looks like at the start, how do you say that? Like
G of f of h of -3.
Oh, okay.
Got it?
G of f of h of -3.
That's right. Okay, any other questions? Okay, everybody, try to do this example up here. Find 4 solutions of y equals 7x. 4 solutions. So we might have to think, some of us might forget, what does that mean? What is a solution? And how are there 4 of them? Okay, so you got to think about that. This is your equation. And they want 4 solutions. I want you to think about what that might mean. If anybody wants to say what that means, you're welcome to say it right now. But one at a time.
It means that give like an input of x and then you'll get an output of y. So you input 4 values for x and then you'll get 4 values for y.
Wow, that was so beautifully said.
Thank you.
So what you could do is this. An XY table. Put 4 values for x, and you're going to get exactly 4 values for y. By the way, is this a function? Hello?
Yes.
Sometimes
Yes.
it is.
Why is it a function? One person can answer.
Because when you're inputting only one x value, you're going to get only like one y value, and you cannot have like more than one value for x. You cannot have more than one y value for x. So it's
Right. Right. I see what you're saying. So, for example, if I were to plug in, go ahead.
2,
Uh-huh.
then you wouldn't get like 14 and 15. You would only get 14.
Right. You can only get one answer. So you can pick whatever x you like. So I'm going to let you guys throw them out. Somebody said 2. Somebody threw out something else.
-2.
-2. One more.
5.
0.
5. Okay. And we'll do 0.
8.
8. That's enough. No more.
17.
I said no more. Haha. Okay. So here we go. If x is 2, you plug that in. 7 times 2 is 14. 7 times 3 is 21. 7 times -2 is -14. Okay. 7 times 5 is 35. 7 times 0 is 0. 7 times 8 is 56. So what you don't see is when I plug in a 2, I don't get out 2 values or more. So this is a linear function, we say, a linear function. So
Mr. Rosen,
I could have written it how? Instead of y, what could I have said? Instead of y equals 7x, what's another way I could have
F
written?
of x
Yeah.
equals 7x.
Yeah. This is a linear equation. This is a linear function. They do the same thing. And what are they? What is a linear equation and a linear function? They have a graph that, guess what? It's a what?
Line.
Yeah.
Line.
If it has a graph that's a line, then it's either a linear equation or in function notation, it's a linear function. Any questions about that?
Yeah.
I'll take any questions.
wait, I have a question. So can you just list any number for x as long as it's not?
Exactly. Why? Why can we list any number for x? Because x is the what type of variable?
Independent.
Independent.
It's independent, which means it's free to be whatever you want to plug in.
As long as there's no two, as long as two of the values don't intercept.
And that's a good thing to mention. There are some situations where, what if x is a denominator?
Then it can't be 0.
Right. So it's not always whatever you want. What about this? Check this one out.
Then it can't be negative. Wait, no, it can. It can't be greater than 2.
It can't be greater than 2. It can be 2, but x must be less than or equal to 2. See that? Now you've gotten rid of a bunch of numbers that x cannot be, because you can't have a negative inside the square root. Okay? So you're not dealing with these, but next year you will deal with those.
So you can just list any random number and then just run it through the formula, and you get.
Yes, exactly. But I'm just showing you here that it's not always completely independent. Sometimes there are things that x cannot be. All right?
It can be limited.
It can be limited, but it's still going to be the independent variable. Okay? All right, and then y depends on whatever you choose for x. Okay? Any questions with that? So this is called we call this an XY table, but we can also call this a function table.
Input, output.
What is another use of a input output? I love that. What's another use of a function table is what is this when I do that with a comma?
That's coordinates.
It's an ordered
Coordinates. It can be, which means it can be what?
It can graph.
Yes. So that means I can give you a linear equation or a linear function.
And then you can graph it.
And now you know how to graph it. You can make up your own table. And the great thing is you get to choose where you want to see the graph. What if I want it to see what it looks like over at x is 1,000,000? Then plug in 1,000,000. What's 7 times 1,000,000?
7 million.
So then if you wanted to graph that, well, I can still graph that even though the numbers are large. But I have to then go 1 million, 2 million, 3 million, 4 million, 5 million, right? 1, 2, 3, 4, 5, 6, 7. I can count in the millions, right? As long as I change this, I can call that y, or I can call that the f of x axis, right? There's 1 million, 7 million if I want it to be. So it's all graphable. It just depends on where do you want to see this graph. Okay? All right, any questions?
And then when you have all your ordered pairs, then they should, when you place them on when you graph them, then they all should make a straight line.
Yes, if it's a linear function,
Yes.
right? If it's a linear function.
Then,
All right, now, let's move on, because I don't want to, I have things that I want to tell you, but they're going to come up as we go through this. Okay, so that's example 1. Okay, when solving real world problems, check that the solution makes sense in the context of the original problem. So you always go back and check to see if your solutions make sense. And I don't mean dollars and cents. Okay, so let's look at example 2 here. All right, and I'll read it out loud for you. Games cost $8 to download onto a cell phone. It's pretty expensive. Ringtones cost $1. Find 4 solutions of this equation, 8x plus y equals 20. In terms of the numbers of games, x, and ringtones, y, Darcy can buy with $20. Now you know what that 20 is for. That's Darcy's budget. Now, because that's not an inequality, by the way, she's not trying to stay below or equal to. She intends to spend all of her money because that's equals. See that? You could rewrite this problem and have a linear inequality. Linear inequality, right? It's just like a linear equation, but if it's an inequality, then you would see that you can be less than or equal to $20. All right, so she's going to buy $8 per game, $1 per ringtone. That's why there should be a 1 there, but you don't need to put a 1. Okay? All right, so what I want you to do, find 4 solutions of this equation. Go. Pretty much the same as we already did.
Mr. Rosenthal,
Uh-huh.
what lesson is this?
This is 9-2.
Thank you.
You betcha. Now, why make things difficult on yourself? I like to pick I typically pick the same set of inputs every time. Or I change them only slightly depending on, I do what makes it easy for me. Okay? So this is a nice set of inputs I like to use. Notice I go in order, I don't skip, I don't go 0, 1, then 3. And the reason I do that is because it allows me to see the slope working. Okay, because as x changes by the same amount, because this is linear, the y is going to change by the same amount. Okay?
She can't buy 3 games though.
Ah, so now you're looking at limitations. You're right. She can't buy 3 games. And you're going to see what happens. The equation doesn't know that, does it?
No.
Ah, so that takes us back up to the slide above.
Yes.
Which said what? When solving real world problems, check that the solution makes sense in the context of the problem.
I mean, she would just owe money.
Ah, okay. She would owe
Or she
money.
could sell. She could maybe sell.
Or she could steal it and just.
But that's not what the
get by.
problem.
Oh, I love that. Okay, so she can buy 3 games, that's $24, and then sell things maybe back to the company worth $4 so that it comes out to 20. That would be your negative, right? That's when
not part of the equation.
Hmm?
Yeah,
Yes, it's a y-intercept. It's not in the equation.
Put negative. You just have to do.
Which one of these is going to be the y-intercept, if any? Are any of these?
0.
No.
I
Or
heard
0, yeah.
0.
No.
when y is 0 or when x is 0?
When x is 0.
When
X.
When x is 0, you are on the y-axis. You can try to challenge me and find some point where x is 0 and you're not on the y-axis. if anybody can do that, I will call somebody and see if we can get you some sort of Nobel Prize.
Oh,
What do you say again?
if x is 0.
X is 0. Oh, I have a situation.
X is 0.
If X is 0, Y is 20.
When there's an imaginary.
Ah, I like that. Imaginary? How about on a Z-plane that comes out towards you? Right?
Of three-dimensional.
Oh, Peace Prize.
Watch this. There's X, the X-axis. Here's the Y-axis. The Z-axis comes through the board out towards you. Right? If I have a point that is at 0, or let's say 0 on the X, and you just come out along the Z-axis, out to here, right? That point is not on the Y-axis, but it has an X coordinate of 0.
X-axis. Well,
Right? So this coordinate could be, it could be 0, 0, 1. 0 on the X, 0 on the Y, 1 on the Z. And
So it's on the y-axis.
It's not on the
0 on the y-axis.
But it's not on the Y-axis. It's not located. Remember, what is a point?
on it.
What is a point? What is a point? It's a what?
It's like
It's a low
Location.
the location. All right, if that's what a point is, a location, then you would say, where is it located? It is not this point is not located on the Y-axis. All right, that's a good discussion. All right, so let's get back to our problem then.
Yeah.
Okay, so let's see, what color do we want? How about red? All right, so here we go. Let's plug this in. So if you're talking about a plane where you cannot come off into 3D, right? You must stay in the plane. Then when X is 0, you must be on the Y-axis because you can't come off with that trick that I just did. Okay, so when X is 0, you must be on the Y-axis. That, whatever that is the Y-intercept. So go ahead and plug that in. X is 0, you have 8 times 0 plus Y equals 20.
It would have to be
First of all, what does that mean? What does this mean in the context of the problem?
that she bought 0 games.
Yeah, I didn't buy any games. That means I have all the money left for ringtones. So this is 0. 0 plus Y is Y. Y is 20.
Yeah.
Remember, this is for what we're getting. This is the output. Okay? And what is Y? Y is the amount of ringtones I'm going to buy. That means I don't want any games. I just want to buy 20 ringtones. Any questions about that so far?
Why would you buy 20 ringtones, though?
Why would I do it? Maybe I want to have a variety that I can switch back and forth from.
Not 20 ringtones, Galileo.
What? You don't even have to pay for ringtones anymore.
In this world.
20 different remixes of Never Gonna Give You Up.
There you go. All right, here we go. Let's say I want to buy 1 game. 8 times 1 plus Y amount of ringtones for $1 each. This is 8 plus Y is equal to 20. I'm going to take the 8 away from what I can spend and from the 8 over here. Y is equal to 12. I don't need to plug in anymore. Why not? I'm done plugging in. Why?
Now you know the slope.
I know the slope.
Yeah.
By the way, what is the slope here? What is M, the slope?
8.
Change in?
-8. Wait.
Change in
Change
what?
in-
Over change in what?
Change in X over change in Y.
Nice try. Try that one more time. Flip it over.
Change in Y over change in X.
All right. So how is Y changing? It's doing what?
-8.
-8. This is a drop of 8 for every it only happens when X changes, right?
By 1.
Right? Because this is a function. You don't get 20 and 12 for the same input. You must change the input to get that.
X increases by 1.
Okay, so one second. I'll get to your question in a second.
Se me hizo el coso que dice, oh, you turned up. Y
You guys
ahora
gotta
no
mute.
puedo encontrar la
You
clase.
gotta mute.
Vuelve otra vez para atrás.
I can't go any
lo único
further
que
until
tengo
you're
ahora
muted.
Ok, ya lo
But can anybody see who it is? They might not know. And
Charlie
Siyun
Joseph
and Mila. Siyun and Mila, your videos are up at the top. You need to turn those off.
It wasn't me.
It's not on. I don't.
It was me, my bad.
Okay, you guys, let's cut that so that we can get back. I'm right in the middle of a thought. You definitely don't want to distract. Okay, so the slope is the delta y. The change in the y is -8. And that only happens when you change x by 1, +1. And if you simplify -8 divided by +1, it's just -8. Your slope is -8. Okay? And that when I use the slope, and that's my strategy was to keep the pattern the same. Remember I told you that's why I chose these. Now I could have gone up by 2, 0, 2, 4, 6. As long as you go up by a pattern, it'll allow you to calculate the slope. Okay? This is going to go down 8 every time this goes up by 1. So now this went up by 1. So guess what? Down by 8. This goes up by 1, go down by 8, and that's going to take me to -4. Okay? Questions about this process?
I started at 1 and then it went 12, -4, 12, 4, -4, 8, or 4, 12. Or -12, sorry.
-12, yeah, right. So you started at 1. You didn't start at 0. Okay, good. So which ones are realistic? Only the first, which ones?
Three.
First 3 are realistic situations in the context of the problem. Because you can't buy half games. The equation doesn't know that. If I plug in a half, I'll get an answer, right? If x is a half, what's half of 8? 4, and then I can
Demo
subtract.
games are free.
You guys, hold on. I can subtract 4 from 20 and I'll get 16. So when x is a half, I can buy 16 ringtones, but you can't buy half a game. So it's not practical.
Unless it's a discounted
What if you
game.
give back games?
Okay, so that's good. That's a good conversation. So for instance, let's look here.
Apple doesn't do
Buying
that.
3 games is going to cost you more than you have. It's going to cost you more than the 20. So you're going to be short -4. You're going to have -4 to spend, which means you're owe $4 that you didn't have. And then you guys came up with good examples. Well, maybe I can sell some things or owe them money. So you're
Yeah,
right on.
it's just on your cable bill and like.
Yeah, there you go. So you're right on. You guys are right there where you need to be in your thought process. That's exactly right. So this goes back to, this is not a practical solution unless you want to consider those extensions, okay? So these are the ones that, let's say that I'm not allowing you to go over, okay? You can only buy 0 games, 1 or 2, then these are really your solutions. All right? Okay,
Mr.
great.
Rosenthal?
Yes.
If you for half a game, maybe a practical half a game could be like 1 game discounted half off.
Yep. Right, get a 50% off of a game, right? So then it's only, but what is X representing? The number of games you're buying, right?
Yeah.
So, I mean, you could do that and say, well, it's only worth half of a game and count it as buying a half game. All right, so let's move on to our next item. Okay, graphing, X-intercept and Y-intercepts. What are those? So let's take a look at that. Graphically, if you guys can see up there, I shouldn't go so close to the screen. It makes it brighter.
Either when X or Y is 0.
Yeah, exactly. Can you guys see that? Can you guys see this okay?
Yeah.
Here's this line, right? Every point on the line is an ordered pair that came from a table, from the equation that made this line. But this point is special, and this point is special. This point is, what is that coordinate that I'm pointing to right now?
Y-intercept.
What specifically is that? Where is this located?
3.
3.
What's the coordinate?
2, 3.
Is it 3, 0 or 0, 3?
0, 3.
0, 3.
It's 0, 3. All right, so when X is 0, this is your Y-intercept. The Y-intercept is 3 in this case. Why is this point special?
The X-intercept.
Yeah, that's where the line crosses through the x-axis? What's that? What's the location of that coordinate on the graph?
2, 0.
3, 0.
2, 0.
That's a
2,
2.
0.
That's a 2.
No, 2.
0.
So 2, 0. Notice what is 0 when you're on the x-axis? Hello?
The origin.
Repeat that.
Okay, let me say this again. For the y-intercept, the x is 0. 0, 3. So for red, the coordinate was 0, 3. That's the y-intercept. For the green one, it was at 2, 0, and that's the x-intercept. Okay, so for the y-intercept, it's when x is 0. 0, 3. X is 0, y is 3. For the x-intercept, it's the other way around. What's 0? Which coordinate is 0 when you're on the x?
The y.
Ah, the y, when the y is 0. So what if I wanted to locate these 2 points? What
Well,
could I
then
do?
you make either y or x 0.
Exactly, that was exactly right. If I want to find both of these points, you'll do it separately, all right? One time you can say, what happens when my input is 0? Then whatever you get for your output is the y-intercept. In this case, it happens to be 3. In another case, it'll be something else. What if I want to find the x-intercept?
Then you have to
Make the output 0.
Yes.
You make the output 0, and you find out what input will make it 0. And that is your x-intercept. Okay? So let's go back up and read what it says. It says here, the x-coordinate of the point at which the graph crosses the x-axis is the x-intercept. The y-coordinate of the point at which the graph crosses the y-axis is the y-intercept. Okay? So let's move on. That's good enough. I think you got it. Okay. I want you to try to graph your own. Try to graph this one. Negative 2x plus y equals 4. How many, before you graph, hold on one second. In geometry, one of our earliest postulates, which is something that's always true, like a property, but a postulate is something that we assume to be true. All right, and we use those to prove things in mathematics. It's also known as an axiom. So I can write those words for you. You're going to get this in geometry. Okay, so I know you have algebra next year, but the year after, you'll have something called an axiom or postulate. Okay, and one of the first ones that you ever learn is this. You already know, you're already going to know this when I say it. Through any 2 points, there is exactly, no less and no more, there is exactly what? Through any 2 points, there is exactly what? Can anybody think of what that would be?
Nothing.
One line.
Yes,
Line.
one line, exactly. One line. So if I pick 2 points
Jacob, you need to
in
turn off your
space,
camera.
anywhere you want in space, pick 1 point and pick some other point,
There's only one line that can
only one line. So you need to turn your video off. Okay? There's only one line. You cannot make 2 lines that are different that go through those 2 points. All right.
But they're not, who says they have to be straight lines?
That's what I'm saying. There's only one line. I'm only talking about lines.
A line
But
is
there can be one line that goes straight at it and another line that curves but still comes in.
Not a line anymore then.
yeah.
So I'm not going to go too far into what the definitions of all of this stuff is. You're going to get that in geometry. But a line cannot curve unless you're talking about on a globe, right? Non-Euclidean geometry is if I walk in a straight line on Earth, I will be walking in a curve. If I walk around the equator, right, or fly over the equator in a straight line, I will curve. But we're not talking about that. In this conversation, we can just keep going with it. But we have to take it back to what we want to link it to what we're doing. We don't want to just veer off, you know, too much. Okay. So what I'm saying, hold on. What I'm saying to you is that through any 2 points, there is exactly one line. So why am I connecting it here? I'm connecting it here because I'm asking you to graph a linear equation. We know it's going to be a line in a plane, not on a sphere, not non-Euclidean, not the equator, on a plane, on a flat surface. We know this is linear. It's going to be a line, and I'm telling you to graph it. So I ask you, how many points do you need minimum to determine a line?
2.
2. You only need 2 points. Guess where you could find 2 points from the last thing I told you? What 2 special points could you find?
X and Y.
The Y and X-Intercepts.
Yes, the X and the Y intercepts. If you just find those 2 points, you can just connect those 2 with one line, and you will have a graph, and that's all you need to do. Of course, you can make a full XY table of a whole bunch of solutions, but that's more than you need. You don't need to do that. So go ahead and see if you can graph this just using the X and Y intercepts. Give it a shot. Go. Take 1 minute. "20 seconds. And it doesn't have to be perfect. You just you don't want to get out your ruler and start, you know, trying to make it perfect right now. You won't have time to finish it. And time. And you'll get more to practice. Okay, so how do I find the y-intercept? What did we say needs to be 0?
The X.
The X must be 0 to find this y-intercept. How do I find the x-intercept?
You would have to make
And the Y is 0.
If I make y 0, I can find the missing x that goes with it. All right, and my equation is here. Okay, so let's do x is 0. When x is 0, what's -2 times 0?
0.
So this is gone. What is y equal to?
4.
4.
If this is 0, then y is just equal to 4. So now I can uncover this, and I can graph it right now. Where is 0, 4? There it is. There's 0, 4. Is that enough to make a line? How many lines possible are there to go through 1 point?
Infinite.
Infinitely many lines. I can have a line that goes through there, and anywhere in between. And in this angle, and that angle, and that angle, okay? So you need a second point. I guess I could do the second point in red. Now, the second point is when y is 0. Okay, well, when y is 0, that means, look, here's the y number line. When y is 0, you're not above this axis, you're not below, and you're not above. You're right on the axis. So that's what keeping y 0 means. You're not allowed to move up, and you're not allowed to move down. You must stay at 0. But I can move left or right. Okay, so let's do it in the equation. Y is 0. Y is 0. So -2x plus 0 is -2x. And then you divide by -2 on both sides. That's it. So x is -2 when y is 0. And where is that point? -2, 0. And it's not an accident that it's on the x-axis. We made it on the x-axis by setting the y equal to 0. Now you have 2 points. And in geometry, we learned the little bit of geometry that I gave you. Through any 2 points, which we have, there is only one line. So the line that connects those is the graph of the line of this equation. That's where a ruler would be good. Okay, that's the graph of my line. Now, I can, when I'm graphing, your point is taking up space. It's taking up area on your paper. So when you put a ruler through, if you don't go right through the right point, your line could be off by a hair. How do I get my graph to look more accurate? If you want your graph to look more points, if you graph more points, your graph will probably be more accurate. Okay, so if I wanted to find out, well, what happens when x is 1? If x is 1, I can get another solution. Another solution would give me another point. But where is that going to be, by the way, when x is 1? Everybody go to x is 1, here.
Y6.
It's going to be up here. But what if I want to find out a point that's somewhere in this region?
What?
And I'm going to choose when
-1.
x is -1, right? If I choose when x is -1, okay, then I go here and it's going to be somewhere around here. Okay, I don't know where. It could be 2. Let's try it. So you come back up here. When x is -1, plug in a -1. The y is still the y, the 4 is still the 4. -2 times -1 is 2, positive 2, plus y equals 4. Okay, and then subtract 2. Y is 2 when x is -1. So I can always go back to what we were doing with an xy table and find other points. But guess what? That point, -1, 2, is also on the line. Now when I'm trying to use my ruler to line that up, I can put it through all 3 points, and that will help me, draw it a little more accurately. But you don't need 3 points. You only need a minimum of 2 points. Okay? All right. Shall we try another?
Yes.
Okay, graph this one. Y equals x minus 4.
Mr. Rosenthal,
Mm-hmm.
you can just list any random numbers and then graph them, right?
That's one way to do it. Or you can just find the intercepts.
Okay.
You need a minimum of 2 points. I'm going to do this. I'm not going to even find the X-intercept. I think we'll be able to find, I think you already know where the X-intercept is going to be. You'll see. Okay, when x is 0, -4. When x is 1, 1 minus 4 is -3. And then follow the pattern, -4, -3, -2. And if you want to go to the intercept, -1, 0, follow this pattern, 0, 1, 2, 3, 4. There's my y-intercept, is when x is 0. And when y is 0, I have my x-intercept. And you'll notice all these other points where they are. There you go. Okay. And that's it. I mean, it's not, the graphing is not so bad once you understand it's an input-output table, a function table, and that there are some special points called the intercepts are helpful. Those, now you have several tools that you can use. Oh, okay. So confused on the way first to count. I don't understand the question. I'm so confused on the way first problem. First problem? Which first problem? The warm-up? F of G of H of X thing? G of F of H of X? That one, Daniel? Never mind. Okay. Any questions? Please ask. Yes.
So can you only use 0, 1, 2, 3, and 4, or can you use any numbers like 5, 6, 7, 8, and 9?
It's independent, so you can use 5, 6, 7, 8, or 9. But where's that going to be on your graph? X is 5 is way over here. Do you want a graph way on your paper, way over here?
No.
Sometimes you need to, because sometimes the graph is way over there and you can't do anything about it. But this graph is not way over there, so it's unnecessary. I mean, if you graph X is 5, you'll be here, right?
Okay,
X is 1, 2, 3, 4, 5, then your answer will be 1, right? 5, 1.
Yeah.
And then 6, 2, 7, 3, right? It's just going to keep going up. 4.
So you're just saying so to be reasonable with your answer?
Yeah, X is independent, so you do get to choose whatever you want from the domain, and the domain is all real numbers, because there's nothing here limiting you like a square root or a denominator where it can't be 0, or a square root where the inside cannot be negative. You don't have a situation like that, so X can be anything you want.
Will there be square roots in the test?
No.
Okay.
That I know of. Okay, moving along. Let's see what we have next for you guys. Okay, try this one. X plus Y equals 2.
I had a question about this problem.
Okay.
The one that's on the board.
Okay.
If the first ordered pair is X is 0 and Y is -4, why are they both on 4? Like both the dots.
Both what dots? 0, -4 is right here. This one is 0, -4 right here. This one.
Oh, because it's not. No, never mind.
Okay?
I confused myself.
No worries. This is fairly new for you guys, so that's okay. Any questions? Okay, so the next problem is X plus Y equals 2. That's like a budget problem. I'm going to buy this many of something for $1. I'm going to buy some other thing and they're $1 each, and I have $2 to spend. So this is called standard form. When X and Y are on the same side of the equation, that's typically standard form. Standard form is where I like to do that. I like standard form is the best. And now if you want to write this down in your notes, when X and Y are on the same side, that's when I like graphing with the intercepts. And this is what I would teach my algebra students when I was teaching algebra. So some students say, well, when do you just do 0, 1, 2, 3? And when do you just do this? I'm telling you when. I suggest you don't have to. It's not mandatory. You can do either way anytime you want. This way tends to work well, usually, when it's in standard form. When X and Y are on the same side, then it's really easy to use the intercepts. Okay, when X is 0, watch what I do. Here's another trick I do. When X is 0, it's gone from the problem. Look at what's left. And when Y is 0, It's gone from the problem. It's 0. Y is 0. So x plus 0 is x. X is 2. 0, 2, and 2, 0. See how fast and easy that is? Questions about that? Anybody? Nobody?
Huh?
No questions?
Wait a second. So you can choose what the x and the y will be as long as they don't add up to more than 2?
They can add up to more than 2, but then the other one will be what?
Less than 2. Less than that, it'll have to be 0.
If x is 3, 3 plus what is 2?
-1.
Ah, so if one of them is more than 2, then the other one has to be negative. Where is that seen on the graph? All of these points here are below the x-axis. All of these y's are below 0. All of these y's, forever. All of these y's are down from the x-axis. All of these are underneath 0, right?
Yeah. So technically,
but what about over here? What if the y is positive and the y keeps going up? Remember, y is up. If the green line goes up, 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 once y, here's y is 2, right there. Once y is more than 2, what are all these points? These are this way from the y-axis. That means the x is all negative now, forever. The x is going to be always to the left of the y-axis. So all the x's have to be negative now. If the y goes above 2, then all of these are in the quadrant 2. All your x's are negative over here. Once the line comes through quadrant 1, here's quadrant 1, all of your x's and y's are positive. Once you go past x is 2, now you're in quadrant 4. That means all your x's are positive, but your y's are negative. Okay? So in these orange regions is where either the x's have to be negative when y is above 2, or when x is above 2, all your y's have to be negative. Okay? All right. Let's move on to this problem. Let's see if you can put this all together now, folks. Let's solve a real world situation. Let me make this a little bit smaller. It's taking up a little bit too much of the page. Let's try 235. I think that fits. Yeah, it does. Okay, after X hours of driving, there are Y gallons of gasoline remaining in a car. This is what's called an inverse relationship. Remember the work problem? When you add more people to help people do a job, remember that problem? The time it takes to do the job when you add more people does not go up. What happens to the time it takes to do a job? When you
Goes down.
It
goes down.
Because
That's an
there's
inverse
more people,
relationship.
so it's easier.
So same thing that they're talking about here. You need to try to spot those. When the more miles a car goes, the less gas there is in the tank, right? So there's going to be a negative relationship there between those, an inverse relationship. So the further I drive, the less gas that's in my tank. Here are the variables they're using. X is hours of driving. So the more hours I drive, the Y, which is gallons of gasoline in the car, should go down. And that happens in the situation we just saw on the last page. Or the songs versus the games, or the ringtones versus the games, right? The more of one you buy, that means you have to buy less of the other. It's that type of relationship is when you see it in standard form, right? When you see X and Y on the same side equaling something, then the more of one means I have to have less of the other in order to still stay 18. Okay, so that's what's happening. And the reason, why is that happening in this problem? It's happening in this problem because the longer you drive, the less gas you're going to have in your car. All right, if I choose to drive for less time, I can keep more gas in my car. If I choose to drive for more time, that's going to take away the amount of gas I have. What is the 18 then? Remember, remember the ringtone problem in the game? $20 was what I had to spend, right?
18 is like the amount of gas, or like.
Yeah, 18 is what I have to spend, right?
Mm-hmm.
Okay.
Mr. Rosenthal?
Yes.
From what I can see on the problem, I can already tell that X has to be less than 10 for it to be practical.
Yes, good. You guys are doing the right thing. Okay, you guys, I'm going to give you another minute starting now to try to go forward on your own. You can ask any clarifying questions you like over the next minute. Go. Five seconds. Time. Okay. When X is 0, what does that mean? What is X? Hello?
Hours of driving.
So if X is 0, what does that mean?
No driving.
No driving. Okay.
Wait. Yeah, yeah.
No,
Because
no.
you can drive for
X
30
is
minutes.
0. No, 0. If X is 0, plug it in here.
And there's a Y intercept.
Hold on. After 0 hours of driving, that's what that is. X is hours of driving. When you put X as 0, you're saying I am not driving at all. So it doesn't matter that it's 1.8 here. It's 1.8 times 0. That's gone. Y is 18. That means I have all 18 gallons of gas left. If I don't drive, so that means that it occurs to you at that point that, oh, this car must have an 18 gallon tank, right? That's the capacity. When you fill up this car of gas, I'm assuming that maybe the car had already used some, who knows? But let's assume that, the car is filled up and it's got 18 gallons. And if I don't drive at all, guess what's still left? The 18 gallons. Now start to drive. Now that means I can put in, what about 1 hour, 2 hour, 3 hour? I can try all those.
10 hours.
But I'm not going to do that. I'm going to say, what if I have no gallons of gas left?
Well, then it's
Why
10.
would I do that? Why would I want to know that?
So then you know how far you can drive, how long
Yes.
you can drive.
Yes, it tells me how far I can go. And then on a map, I can plan ahead. I can say, okay, I better get gas at a certain point so I don't run out. And what is the cars all keep track of your mileage, don't they? Yeah, so that's a good point to know, is what's the most? It gives me the maximum before I run out. So when I run out of gas, then the amount of gallons of gas I have in my car is 0, Y is 0, then I'm left with 1.8 X equals 18, and I can solve that. Divide by 1.8, and kind of do that in our heads. 1.8 goes into 18 exactly
10 times.
So and X, remember, go back, it's hours of driving. That means I can drive 10 hours before I run out of gas. It doesn't mean I'm going to try to do that. It just means that that's a range that I'm looking at. If I want to graph that, no problem. I have these two intercepts. The numbers get kind of large. So now watch, I'm going to show you a little trick. What quadrant do I need? I can really just do quadrant 1 because I'm going to be on the axes. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm going to cheat and extend this.
Ooh, and tell teacher.
18, 19.
Cheating.
There's 20 and there's 18. Okay, so here's 18. 0, 18 is right here. What does the y-axis represent? Gallons of gas in the tank. So that point means I've driven 0 hours, because this is hours. I haven't moved to the right. If I move to the right, that means I'm driving. If I've stayed back here, I haven't driven at all. This is gallons of gasoline, okay? If I start driving, what happens? As I drive, it doesn't stay 18 gallons of gas. What would this mean? If the line went that way, what would that mean? I'm driving an electric car. I'm not using any gas. I'm driving for hours and I'm not losing any gas. That's what a flat line would mean. What if I went straight down? What would that mean?
You're losing.
What means
I have a leak. My car is just sitting there. I'm not driving and I'm leaking gas. All right, but that's neither of those is the situation here. It would be a different. Right. So what's going to happen is I don't need all the in-betweens. I can just use the other intercept. I can drive for 10 hours, and what does that point mean? I went 10 hours that way, and guess how much gas I have? I went all the way from 18, and now I'm down
With 0.
0. So then how many lines between 2 points?
1.
Practically, can I go into quadrant 2 here or into quadrant 4?
No, because you can't have negative hours.
I can't
You can't have negative gas.
Over here, past this boundary line, that's negative hours. What's this boundary line? Why can't I drop below?
Negative gas.
Negative gas.
Negative gas, right. Negative gallons of gas. So really, my graph is bounded practically there and there.
In quadrant 2.
In quadrant 1.
1? Oh, yeah.
Yeah. Okay, so that's it. And now we've interpreted the X and the Y intercepts. That's 0 gas after 10 hours. This one is 18 gallons of gas with no driving. You guys did a great job on that. Any questions?
Are we dismissed?
No. Let's see what else we have.
There's homework after this.
There you go. Now, I'm going to put this up and you'll see your homework. And now you're dismissed. Office hours begin. See you tomorrow.
Okay.
Bye, Mr.
I have one question.
You can ask as many questions as you want, as you like. I'm on office hours now.
Okay, so first thing, I didn't really get that thing about the retakes of the tests.
Retakes will all be available this Wednesday from 3 to 4:30
Where?
in your Zoom test folder.
Gotcha.
Are you posting this homework on Schoology?
It already is in there.
Oh, great.
Okay, next.
Thank you.
So
Mr. Rosenthal, was this 9-2 or was it 9-3?
This was 9-2.
Oh.
Isn't that nice?
Oh, I thought it was 9-3.
No. We have more exciting stuff for 9-3.
It was a long chapter for 9-2.
Yeah, I mean, we have to be careful here and make sure you guys are understanding this. I mean, this is where algebra is going. It's going to go into the coordinate plane a lot. So in algebra 2 and calculus, you really have to understand functions and the coordinate plane.
Yeah. So I have a question about the work we did. G and then like G and then parentheses F parentheses H parentheses -3 and that said find.
Uh-huh.
I didn't understand that.
Okay, so those are each function machines. You know, function machine is I put in an input for X and I get out the value of the function. So H of -3 means that I put in a -3 into the H equation. And there was an equation here. Now I don't have it up here. I just made it up on the board. So it's gone. But H of -3, I plug the -3 in and I get an answer. Just like we did here, you plug in and you get an answer. Once you get an answer, then I had to plug it into the F equation. And I plug it in for X. That's my input now. Whatever the answer was for H of X, H of -3, whatever the answer is, see the input of -3, look over here and think, what if I put in a -3? I'd get something, right? I'd get a number. You take that number, and now that's your new input for F, the F equation. And you plug that in and you get a new answer. And whatever that answer is, you plug it into the G equation. And I had 3 separate equations at the beginning. So you could plug it into each equation as you got to it. Okay?
Mr. Rosenthal,
Uh-huh.
for the test, like for chapter 9, I know like obviously there's gonna be a question when it's like graph this equation. So like how do we do that like in the answer key? Should we just do like a mini?
You'll see.
Okay.
And we'll when we do the review, I will show you that.
Okay.
Okay?
Thank you, Mr. Rosenthal.
Oh, you bet.
Okay, I have another question.
Okay.
First of all, is chapter 6 going to be able to be retaken?
All of them will be available. You can pick one to retake. You cannot do more than one.
Second of all, how do you find sales tax?
How do you find sales tax? You're given a percent of tax. So let's say tax is 6.25%. Okay. And you buy a bunch of groceries and it comes out to $52 plus tax. Okay, so now I need to find 12.0625 times the 52 is one method. And that will find, when you do this, you're finding how much money is the tax that you're paying. All right, so if the question is how much tax is that in dollars, I would just do this problem. All right, if I want to find out how much do I end up paying, what's my total price that I'm going to pay with tax, then I can take that value and add it to the 52. Or I can calculate it all at once by doing the same problem, but by putting a 1 there. Instead, look at these two side by side. What's the difference?
No difference.
There is a difference. What do you see? Here's a decimal and here's a decimal. What do you see to the left of each decimal? Same exact thing?
No.
No, so there's a difference.
But the 1 doesn't make a difference in what happens in the equation.
It does. 52 times 0 is 0. 52 times 1 is
52.
What? That gives me the $52.
Okay, but that's not the question I was asking. I was asking, how do you find the actual tax? I'll read this from the. No, no, that's not what I mean.
Oh, what if you don't know the tax?
Yeah, like Chan bought a $345 smartphone, but his total was $365.7.
Give me the problem.
Okay. Chan bought a $345 smartphone, but his total was $365.70. What percent sales tax did he pay?
Got it. Okay, so this is what he was charged, and then he had to pay tax. So the first thing I'm going to do is I'm going to find out the amount of tax that he paid in dollars by subtracting those. $20.70 was the tax. Percent tax is the amount of tax divided by the original amount of money. Okay, so that amount of tax was decided based on the $345, and then you pay a percent of that, and it comes out to this. But it's simply the formula for finding percent of tax, or increase or decrease, or discount, is the amount that you were taxed over the original, the amount of increase over the original, the amount of decrease over the original, the amount of discount over the original. It's the same for all of them. When you divide this, you can even do it in your calculator right now, or by hand. That's fine. You get this. And what is that percent? What percent is 0.06?
6%.
Yeah, it was a 6% tax.
Okay.
Okay.
Thank
So
you.
the key is the amount of increase or decrease over the original. All right. Any other questions? No?
One more question.
All right.
How do you find percent error?
So percent error is slightly different in the formula. So percent error is when I want to predict something. Let's say you're at a carnival and they have that game where they have a jar of Starburst, right? And whoever guesses the closest to the amount of Starburst in the jar wins the prize, right? Let's say that you saw a big jar of Starburst, and you're making a guess of how many are in there. And you think that there are 200, let's say you think that you go with a round number. I think there are 300 Starburst in the jar. You come to find out that there were really only 290. Okay? What you want to do is you want to find out the amount of error and divide by the actual number that it was supposed to be.
So the percent error would be 10%?
No. The amount of error would be 10. You're skipping all the way to the end without having to do any math. That's not what we want to do. What did I say here? Amount of error, right? Did you find that yet? How far was my guess off?
10.
There's your numerator. What was the actual number of Starburst in the jar?
300.
No, that was my guess.
90.
Right. This is the actual right here. So it might help you to label these things on a test, on your paper. Which one was the guess? Which one was the actual? Have the formula in your notes next to yourself so you can follow this. And then you label it and follow the formula. So 290. Now divide. 10 divided by 290. 10 divided by 290. And I get this. Okay. What percent is that? Rounded to the nearest tenth of a percent.
3.4%.
Yep. Error. That means your guess was almost 3.5% off.
Thank you, Mr. Rosenthal.
You bet. Any other questions?
See you later.
You got it.
What was the formula for simple interest?
Simple interest formula. I equals PRT. I is the amount of total interest over the life of the investment, loan, borrowing, what you borrowed over the life. So I is the interest, principal times rate times time. So this is the total interest made. So if you're borrowing money for 36 months and you're paying interest on that, but they tell you that you're going to pay $20 per month of interest, that is not I. I is 36 times 20. You're going to pay $20 a month for 36 months. So you need to find out the total amount of interest being paid here. The principal is the original amount of money borrowed or invested. So it'll always say this person invested $2,500, over this much time. In 36 months, you already have the time. Put that in years. This is going to be 3 years, right? So if I tell you $4,500 was invested and I'm paying this much for 36 months, and you do this, you're going to get 720 here. This principal will be $4,500. And then 3 years. Now you have this equation. As long as you know where these came from, then you can do that. And then I can multiply those, right? So 720 is equal to 13,500 times R. And then I can divide by 13,500 on both sides. And when I divide, I'm going to get a decimal. And then what percent is that? Rounded to the nearest 1/10 of a percent. Okay.
Okay.
Questions? Anybody else? Kenneth, Ryden, any questions? All right, I'm going to end the session. I'll see you guys tomorrow.